So in our last notes, we covered our first inverse trig function was just the sine function. Now we need to go over the next two, which are going to be cosine and tangent. And they're going to be very similar. So remember, just like with our sine function, we had to restrict the original function to a specific domain in order for it to be one-to-one, which had to happen because we need our inverse function to be a function. And the only way that can happen is if our original function is one-to-one. So we're going to have to go through a similar process for our cosine and tangent. So for cosine, remember that our original function starts at our maximum and ends at a maximum at 2 pi. Halfway in between is our minimum. And then halfway in between each of those is our 0. And then it's going to continue in the same fashion, just like our sine did. Now remember that in order for a function to be one-to-one, it needs to pass our horizontal line test. And again, just like sine, because cosine is periodic, it doesn't pass our horizontal line test at any point, basically. So our goal is, again, to pick a piece of our graph that does pass our horizontal line test and restrict it so that way we will just use that portion. And again, we want to make sure that we get all of the values. So if we start at 0, 1, notice that if we come down all the way through to our minimum, we've hit all of our y values from -1 to 1, and that portion will pass our horizontal line test. So notice that our domain that we've restricted it to is going to be from 0. And then remember that our second maximum happens at 2 pi, and our minimum is halfway in between that, which would be at pi. Our range is still going to be like normal. It's from -1 to 1. So remember that this is our cosine function. And then we also then need to translate that to our inverse function. And it has a very similar look that our sine function did. So it's y equals either arc cosine of x or we'll see it as y equals cosine inverse of x. And they mean the same thing. So remember that to find an inverse, I'm going to switch my x's and y's, which means I'm going to switch the domain and ranges. So our domain for our inverse cosine will become that -1 to 1. And our range will be the 0 to pi. Now notice this time that because we've restricted it from 0 to pi, when I'm looking at my angles, I'm looking at the first and the second quadrant. So those are going to be the type of angles that we look at. Now, thinking back to our tangent function, remember that our tangent function starts and ends at an asymptote. It goes through our origin, which is at 0, 0. Then we have our key point at 1 on the right side, halfway in between the 0 and the asymptote, and our key point at -1 on the left side, halfway in between our 0 and our asymptote. And then again, it's going to repeat itself. And just like before, notice that our graph does not pass the horizontal line test. So again, we need to restrict our domain. So if we look at this, notice that again, we want to pick a piece that kind of is all together. We don't want to look at like two separate pieces. So we wouldn't want to start at 0 and then go to pi, because if we did that, we would hit all of our y values, but notice that it would be broken apart in the middle by an asymptote. So instead, we want to start at that asymptote that's before our y-axis, which recall is at -pi/2. And we will end at pi/2. Now, notice this time I'm using parentheses instead of square brackets. And the reason for that is because remember that at -pi/2 and pi/2, we have asymptotes. So those aren't technically included in our domain. And then recall that my tangent graph is different than the others because they go on forever towards my asymptotes in both directions. My range is going to be -infinity to infinity. And again, when I'm looking at my inverse, I'm going to be either looking at y equals arctangent of x or y equals tangent inverse of x. And you'll see it either way. So again, remember that we're switching our domain and our range from our original. So my domain becomes all real numbers, or -infinity to infinity. And our range becomes -pi/2 to pi/2. And this time, notice that if we're looking at our angles, these would be in our first and fourth quadrant for our outputs. So our sine and tangent intervals are going to be the same from -pi/2 to pi/2. The only difference is that for tangent, remember that -pi/2 and pi/2 aren't included. Our cosine one is the one that's a little bit different because it's from 0 to pi instead. And here's a little bit more of a concise way to look at it. So notice that for both our inverse sine and our inverse cosine, our inputs or our domains or x values have to be between -1 to 1. Our outputs, which are those ranges that we talked about, for sine is -pi/2 to pi/2, which is the same for tangent, but notice that we don't have equal to bars for tangent. And then for cosine, it's 0 to pi. And that's going to be important because notice that underneath we have that property that we talked about yesterday where our sine and our arcsine, or our cosine and our cosine inverse, or our tangent and our arctangent, they undo each other, which is going to be true. But remember that those values that we're undoing, sometimes we might have to rewrite so that they end up in that interval that we need them to be in. And so it's going to be important that you know each of these intervals for the 3 inverse trig functions. So let's look at some examples of evaluating. So our first one is find the arc cosine or cosine inverse of square root of 2 over 2. So notice that arc cosine, again, we're thinking, okay, this time we're plugging in a number and we're going to get out a angle. So we're thinking, what angle gives us cosine of square root of 2 over 2? Well, that's going to be at my pi's over 4s. So it's positive. So cosine is positive in our first quadrant and also in our fourth quadrant. And so the angle that has a reference angle of pi over 4 in my fourth quadrant would be our 7 pi over 4. Now remember, for cosine, if we needed to remind ourselves, we need to be between 0 and pi. Well, out of those two, the only one that's between 0 and pi is the pi over 4. So that one would be our answer. So for cosine inverse of -1, again, I'm thinking backwards. At what point, what angle does cosine equal -1? Well, remember that cosine starts at our maximum value for our graph at 1 at 0. And then we know that it also ends at 1 at 2 pi. And then we know that halfway in between, excuse me, is our minimum, which is -1, and that occurs at pi. And again, we go back, check our interval. Our interval is 0 is less than or equal to y is less than or equal to pi. So we're okay to be equal to pi, and so that would be our answer. On our next one, we're dealing with tangent. So we need to find arctangent 0. So we're looking at, okay, where does tangent equal 0? Well, the way that I like to think about it is, remember that tangent is sine over cosine. And so we know that tangent will be 0 when sine is 0. Because then we would have 0 divided by whatever cosine equals. And we know that sine starts at a 0 at 0. It ends at a 0 at 2 pi. And then also halfway in between is pi. Again, though, if we go back and we look at our tangent, it has to be between -pi over 2 and pi over 2. And the only one of those three that's within that interval is our 0. So that would be our answer. Lastly, we're looking at tangent inverse of -1. So remember that, again, like I said, tangent is equal to sine of x over cosine of x. So in order for sine or for tangent to be 1, that means sine and cosine would have to be equal. In order for it to be -1, one of them would have to be negative and the other would have to be positive. Well, remember, the only place that our sine and cosine are equal are at our pi's over 4s, because they're both square root of 2 over 2. But we know that in our first quadrant at pi over 4, they're both positive, so tangent would also be positive. In our second quadrant, sine is positive, but cosine is negative. So we know that in our second quadrant, tangent would be negative as well. So we want to think, what angle in our second quadrant has a reference angle of pi over 4? Well, that would be 3 pi over 4. In our third quadrant, both sine and cosine are negative, so we know that we would end up with a positive tangent, which isn't what we want. So we would go to our fourth quadrant, and again, think, okay, what angle in our fourth quadrant has a reference angle of pi over 4? It's going to be 7 pi over 4. So we need to go back to our tangent, and we know, okay, they need to be between negative pi over 2 and pi over 2. But if we notice, 3 pi over 4 and 7 pi over 4 aren't within that interval. However, let's think back to the first thing that we did. Okay, well, we know that my tangent angles are in my first and my fourth quadrant, okay? Well, 7 pi over 4 is in our fourth quadrant. It's just not written in the correct form, because we know that if I have an angle in my fourth quadrant, well, to go counterclockwise would give me the positive angle. So that would be the 7 pi over 4. The coterminal angle, which is what's going to be left over, would be this piece right here. Well, I know that all the way around is 2 pi. If I know that the blue portion is 7 pi over 4, I know that the leftover portion has to be pi over 4, because 7 pi over 4 plus pi over 4 would give me 8 pi over 4, which gives me that 2 pi. But again, remember that in order to get it within that correct interval that we need to go backwards or clockwise now instead, which would give us a negative angle instead, so we get a negative pi over 4 as our answer this time. So the biggest things with any of these are just making sure that your final answers are going to be in that correct interval for whichever function that you're finding. Okay, the other thing that's going to be really important is that you need to be able to refer back to either your graph and be able to think about, okay, when would this function have this value on my graph? Or think about your unit circle. When would this function have that value on my unit circle? So again, remember that our tangent and our cosine inverses are going to work very similarly to our inverse sine, meaning that my tangent and my arctangent are going to undo each other, and my cosine and my cosine inverse are going to undo each other. However, again, the big thing here is going to be that we have to make sure that we're within the right interval for our things. So notice that on my first one, I have the tangent on the outside and the arctangent on the inside. So if I go back to my intervals, that means that I'm looking at that first one with my x's. And it tells me that x can be any real number. So as long as x is a real number or the inside is a real number, that's what it's going to equal. Well, negative 5 is a real number, so that's just going to be my answer. So next up, I have cosine of cosine inverse of pi. So again, I want to go back to my intervals and look at cosine. But be careful here, because if I'm looking at the arccosine of y, where the cosine inverse is on the outside, well, then it would just be pi, because my y value tells me it needs to be between 0 and pi. But if we look at the problem that we have here, notice that my cosine is what's on the outside. So I need to use the interval for the one that has the cosine on the outside. And if I look at that, that's this one right here. So that means that I'm using the x's, just like I did with my tangent. Well, my x's tell me that my x has to be between -1 and 1. Well, pi, okay, well, pi's a number, right? But what is pi equivalent to? Pi is equivalent to, remember, 3.14. And notice 3.14 is greater than 1. Therefore, pi is going to be outside of that domain that we're allowed to plug in, which means that I can't do this. So this is going to be undefined. Now, the last thing that we need to look at is the whole reason why we use our inverse functions. And that's because we want to be able to use these in different types of examples. And so sometimes when we use these in different types of word problems or things like that, we're going to end up with things that we need to plug into our calculator. And we have a inverse function, inverse button on your calculator. It's going to be underneath so instead of just clicking the sine, the cosine, or the tangent button, you would click second and then your sine button to give you sine inverse. You would click second and then cosine to get cosine inverse, and then the same thing, I would click second and then tangent to get my tangent inverse. Now, when we're using our calculator or when we're talking about real-world applications, usually we're going to be in degrees. So for these problems, I'm going to work them in degrees. So my first problem is arctangent or tangent inverse of -8.45. So I'm going to go to my mode on my calculator, make sure that I'm in degrees because that's the mode that I want to be using. Then I'm going to click my second button, my tangent button. Then I'm going to type -8.45, and then I'm going to click enter. And it's going to give me -83.251 degrees. So make sure that you're following those steps and can get that same answer. For my sine inverse, I'm going to do the same thing. I'm going to type in second, then sine. I'm going to type in 0.2447 and click enter. This time, I get 14.164 degrees. And then lastly, for my inverse cosine, I'm going to click second, my cosine button, and then I'm going to type in 2. Well, your calculator should give you an error, and it's probably going to say a domain error. And the reason for that, if we go back to our intervals, notice that we said the domain for our cosine is between -1 and 1. Well, 2 is outside of that domain. Therefore, we can't plug it in. So this does not exist. Or you could put undefined. Either one would be fine. Now, like I said, the whole reason that we want to be able to use these is because sometimes we'll run into problems where we need to work our way backwards. So we've looked at some different types of application problems, but all of those were when we were working towards finding a side instead of an angle. Well, now, because we have our inverse, we can find our angles as well. So this says, a television camera at ground level is filming the liftoff of a space shuttle at a point 750 meters from the launch pad. Let theta be the angle of elevation to the shuttle, and let s be the height of the shuttle. Our first part tells us to write theta as a function of s. So we need to look at, okay, I have my theta, which is fine, and then I have the opposite side, which we're just labeling s, and then we have the adjacent side, which is 750. So we need to think what trig function is opposite and adjacent. Well, that's going to be tangent of theta. And tangent of theta is opposite, which in this case is s, over 750. But it asks us to write theta as a function of s. And if I'm writing something as a function of another variable, what I'm saying is that I want that variable to be solved for and to be by itself. And then on the other side, I need to have the s, in this case, in that equation. And our problem right now is that we have a tangent in front of our theta, so it's not by itself. Now, be careful here, because a really common mistake is that people want to try and divide by a tangent. Well, remember that tangent is an operator, or is an operation, just like a square root. And if I had the square root of 4, I can't just divide by the square root. Or if I had the square root of x, I can't divide by the square root in order to get x by itself. I would have to do the inverse operation, which would be squaring it to both sides. And the same thing is going to be true here. In order to get the tangent to go away, I need to take the inverse tangent of both sides. And what we do to one side, we must do to the other. So I'm going to have to take the inverse tangent of s divided by 750 as well. Well, on my left-hand side, because I have tangent inverse of tangent, that's just going to equal theta now, because they undo one another. And then on my right-hand side, I would just be left with our function. So I have tangent inverse of s divided by 750, and that would be our function. Now, part B just asks us to evaluate this when it is 300 meters away and when it's 1,200 meters away. So all I'm going to do for this is plug in those two values. So I would have tangent inverse of 300 divided by 750. And this value is not going to be on our unit circle, so we just need to use our calculator. So again, using that tangent inverse button, so second, tangent, plug in 300 divided by 750, and we should get 21.80 degrees. Again, we're working an application problem, so we're going to put our mode in degrees. If you got a funky answer or a different answer than mine, I would first check your mode, make sure that you're in degree mode. Then it also gives me a second one, so I have tangent inverse of 1,200 this time, divided by 750. Again, this is not going to be on our unit circle, so I'm going to use my calculator, and I should get 57.99 degrees. And this will work for any of our functions. So depending on what two sides they're given, we might need to use our sine inverse or our cosine inverse instead. But we can use these inverse trig functions to help us work our way backwards to figure out what an angle would have to be in order for those two sides to be what they are.